So as I was saying before, I said that it is a IP address is a logical address and it's 32 bits, as I say, as you can see on the board. Then each group of it is 8 bits. 8 bits. That means 8 bits, 8 bits, 8 bits. And 8 bit is what we refer to as octet. So in a short definition, IP address is a 32-bit logical IP address. No, IP address is a 32-bit logical address with 4 groups of octets with dots as their delimiter. Now each one is octet, octet, octet. There are 4 of them, and they are separated with dots. So that is just a short definition of what IP address is. Now, each of the octets, of course, I said is 8 bits. Each one is 8 bits, 8 bits, 8 bits. Now we should know also that when 8 bit is full, like 1, 2, 3, 4, 5, 6, 7, 8. That's when it is full. But it can actually have other things like it can have 1, 0, 1, 1, 0, 1, 1, 1. For instance, it's not full, but it is full with 1, 2, 3, 4, 5, 6, 7, 8. When you have all ones, all true. So that is when we refer that it is full. Now let's take it now. When it is full, that's 1, 2, 3, 4, 5, 6, 7, 8 of them, the octets. If I want to convert this binary, because it's in binary now, to decimal, it's supposed to be, okay, before I talk about that, as I said before, there are octets, 4 octets, 4 groups of octets with dot at the delimiter. And each octet cannot be more than 255. It only ranges from 0 to 255. So you can have octet in IP address as 256. So when it is 0, it is when this octet is empty, kind of this. But when it is full, 255 is what you have as this. So how do you convert binaries to decimal? As in the decimal that we use as human, because in our numerical notation or standard, we are using base 10, but that's what we now put in the system or on the network device. Network device will now convert whatever thing that we put into binary and use. So how do we convert binary to decimal? This is when it is full, 1, and all of that. So let's convert to binary, to decimal, sorry. If I put it like this, I just put in my mind, I put 0, raised to power 0, raised to power 1, raised to power 2 here, raised to power 3, raised to power 4, raised to power 5, raised to power 6, and raised to power 7. So for me to convert, I will now do this one times 2 raised to power 7 plus this one times 2 raised to power 6 plus this one times 2 raised to power 5. That is the 5 on top. So this particular one, that is also for plus times 2 raised to power 4 plus 1 times 2 raised to power 3. That is this particular one plus this one times 2 raised to power the 2 I put on top plus this one times 2 raised to power 1 plus this one times 2 raised to power 0. 2 raised to power 7 is what? 128 plus 2 raised to power 6 is 64 times 2 times 2 times 2 times 2 times 2 and all of that plus 2 to the power 5 is 32 plus 2 to the power 4 is 16 plus 2 to the power 3 is 8 plus 2 to the power 2 is 4 plus 2 to the power 2 is 2 plus 2 to the power 0 is 1. So if you add everything all together, you now have 255. That is when octet is full. That is this. I just converted this to decimal. I will now have 255. So generally, what I'm supposed to be doing is that at this particular point, I put 128. Here is 64. Here is 32. Here is 16. Here is 8. Here is 4. Here is 2. Here is 1. So now, that's what I was supposed to have put on top of them to make it easier. Now, if someone say I should convert something like a 10110011, for instance, I know that this particular one is 128. Where there is 0, I don't count it. Here is 0. 0 times 2 to the power 6 is still 0. So here is, where I have 1, here is 32. This one is 16. This one is supposed to be 2. Here is supposed to be 1. So if you add it together, I'm just giving you a shortcut. If you add everything together, it's going to be 128 plus 32, 160 plus 16, 176 plus 2, 178 plus 1, 179. So this guy, I've converted it to 179. If you want to follow this method still, the one I used before, you can still use it to, you can still do 1 times 2 to the power 7, 0 times 2 to the power 2, 0 times 2 raised to the power 6. And no, anything that times 0 is still 0. But instead of doing those, you can just memorize these digits. 128 divided by 2 is 64, divided by 2, 32, divided by 2 is 16, divided by 2, like that. Make sure there are 8 of them. So wherever you see 1, you just put that particular number and add up. That's the way to do it straight away. So if I have another number, like for instance, I have 0, 1, 1, 0, 1, 0, 1, 0, for instance. What I need to do is, since I know here is, I don't know where there is 0. Where there is 1, I put 64 is supposed to be here. Here is 32. Here is 8. Here is 2. If I add everything together, 64 plus 32 plus 8, I have 104 plus 106. So 106 is this. So that's how to convert binary to decimal. I'm just putting it this way because if we really learn this thing, just trying to kind of refresh our memory on what we've learned before. So if you have any question, if you don't have any question, I need to continue. If you understood what I did. Hello.
No question.
Okay, so we are going to continue. Hold on, coming. So IP. I'm coming back to that, the same IP. Let me get my file. IP. Where are you? Sorry, I'm coming now. Okay, see, back to where we were before. Now, if you look at what we have here, we have a binary case of, see the binary case we have here. 1110000. We have 101 1 and all of that. And they were converted to decimal. So if you have this number in binary, if you want to convert it to decimal, where you have 1, you see 128. That's why they brought 128 here. Where you have 1, 64, 664. Others are all 0. You just do 128 plus 64. It gave you 192. We have another line. We have 128. This one, 32 plus 8. The rest are 0. So if when you add 128 plus 32 plus 8, it gives you this. We have another one. It's only 1. So that's why you have 1. You have it as 1. The next one is this. We have 4 and 1. We have all 1. So 4 plus 1 is 5. So the IP address is 192.168.1.5. That's what we have here. That's kind of the summary of what I showed you, how to convert binary to decimal. So I'll be entering, this is just about IP bits, how to convert from binary to decimal. Now, if you're converting from decimal to binary, I have 192 here. What I need to do is that if I'm converting 192 to decimal, what would I have is that I'll just check. I'll use this. What I will just need to check is in 192 as a bit, can it contain the utmost bit, which is 128? Yes, it can. I take 128. Now what is 1, 1, 1, 1, 1, 1, 1, 1. So if you can accommodate 128, I take that one. This is this one. And now subtract the 128 that I took. What do I have? If I subtract, I have 64. I'll now check the next bit, which is 64. Can I accommodate inside that 64? Yes. I just take that 64. That is this particular one. I subtract the 64. I have all 0. So the remaining ones are all 0. Make it 8. 1, 2, 3, 4, 5, 6, 7. So that is why we now have this. So if I want to convert the other one, which is 168, as in this 168, that is, I'm converting 168. I'll just check the utmost bit is what? 128. This is 1 here, this is 1 here, this is 1 here, this is 1 here, 1 here, 1 here, 1 here, 1 here. I'll just check, can 64 accommodate the utmost bit? Yes, I will take it, which is this particular one. And the value of it in binary in decimal is 128. So I subtract it, I have 0, I have 40. I now check the next one is 64. Can you accommodate it? No, I put it as 0. I'm not subtracting anything. So the next one is 32. Can you accommodate 40? Yes. And that is the one here. So I take that one. And the value of that one is 32. So if I subtract it, I'm going to have 8. I check the next bit, 16. Can you accommodate it? No. The next bit is what? Is 8. So I take that and subtract by 8. I have 0. So if I count 1, 1, 2, 3, 4, 5. So remaining 3 more 0 to make it 8. So that is how we got this. Then coming to 1. Coming to 1, if I want to convert 1, utmost bit is what? 128. it doesn't, it can't accommodate it. The next one is this, it can't accommodate it. The next one is this, it can't accommodate it. The next one is 16, no, it can't accommodate it. The next one is 8, no, it can't accommodate it. The next one is 4, it can't accommodate it. The next one is 2, it can't accommodate it. The next one is 1, can it accommodate it? Yes. 1 minus 1 is 0. So this is binary for 0, for 1, sorry, see it here. The next one is 5. 5. If I want to convert 5, the utmost bit is 128. I can't take it. You can't put it inside 5. Is it 0? The next one is 64. No, it can't go. The next one is 32. It can't accommodate 5. 5 cannot accommodate it. 16. 5 cannot accommodate it. And 8. 5 cannot accommodate it. How about 4? Yes. So I take 1. I minus the 4. I have what? 1. The next one is what? 2. It can accommodate 1. I put 0. The next one is 1. Of course, I can take it. So I take that 1 and subtract the 1. I have 0. So there are how many? 8 of them. So that is how we got this. So that's how to convert binary to decimal and decimal to binary. You can have other numbers. For instance, I can have something like, give me any number. Someone should give us any number so I can convert it. Call any number of your choice. Please, can we call any number so I can just quickly convert it?
176.
176. 176. So let's convert this to binary. The first bit is 128. Can I accommodate it? Yes. We'll take that one and subtract 128. When we subtract, we'll have 8 and 4. The next bit is what? 64. It can accommodate 48 cannot accommodate, you take 0. The next bit is 32. Yes, you can take it. You take 32, which is that we subtract 32. When you subtract, you're going to have 6 and 1. The next bit is what? 16. Can you accommodate this? Yes. So you subtract 16. You have 0. So you need to convert everyone to make it 8. So you have 0, 0, 0, 0. So this is for 176. If you want to convert it back to decimal, here is 128, of course. Here is 32. Here is 16. So if you add all of them together, you have 176. So in summary, that's just the way to convert decimal to binary and binary to decimal. Then going back to other ones. No, this is not what I want to share. Okay. Now in the network we can have different networks and their IP addresses. We have not to talk about this thing now. Let me talk about subnetting. I think that one is better first before we talk about that. Now, subnetting, whenever you give an IP address to a host or to a network device, you always put the subnet mask. This is very important place because when you get this thing, if you don't grab it here, you will understand IP subnetting. So this is the foundation of that subnet. You need to grab it here. So this is IP address. This is subnet mask. Subnet mask is actually It's just a group of octets that we use to identify the network an IP address belongs to. When you look at this place now, I have hold on please. Okay. So here, this is an IP address.
Toy.
Okay. You want to ask a question?
I can't hear you. Your network is breaking. I don't know if it's my network.
I can hear you.
Okay, network. My network. I lost network kind of before sometime, but it's fine now. So
Okay.
now this is my IP address. This is my IP address, and the subnet mask is 255.255.255. That is this particular 255. Now, what this thing is actually telling me is that from, you see, I have, this is the first octet, second octet, and third octet. It's telling me that from here, first to the third one is network ID, network identifier, while the last one is host identifier. As in what I mean by, I mean network ID and host ID. So I use subnet mask to identify my network, or to identify my network ID. That's to identify my network, yes. So where I have 0 here, I'll just mirror it to this, my IP address. So this is where I put IP address to my hosts. But all my hosts in a particular network will have this as kind of their surname. Something like this. Let me bring out something like this. When you look at this place now, everybody here answers the same surname, 192.168.18, 192.168.18. This one, 192.168.5. But their host ID or host number varies. This one can take .11, .22, .3, but they all have the same surname, which is their network. Their network is this 192.168.5.0. This is their network. I'll talk more about that. So back to what we were talking about before. So that's what subnet mask does. So when you now separate your network, and when you inside of your host ID, you have it as 0. It is a network address. This is a network address because of host ID is 0. But when there is something inside the host ID, like 66 or like 44, as far as it's not 0, this is an IP address. Whereas this one is a network address. The same thing with what I showed you before. This is a network address because the host ID is 0. This is an IP address, IP address, IP address, IP address, IP address, IP address, network address. You see that is 0. The host ID is 0. So when you have your host ID to be 0, it is referred to as that address is network address. And we don't assign network address to systems. Okay, that's just by the way. But the major thing you need to know is this classes of IP address. We have class A B, C, D, and the rest. Now, this internet governing body, we have so many of them online on IEEE, the ITU, and EIE, EIA, TIA, and many of them. They make rules and protocols and standards that governs internet and intranet. Everything about internet and intranet, both softwares and hardware design. So one of the stipulation they made on IP address is that they classify IP address into 5 classes. And they now say that class A is any IP address that starts from 1 to 126. This is wrong. 1 to 126. 127 is loopback local host address. Loopback. I'll talk about that later on. Loopback localhost address. So this 127 is from 1 to 126. Although partly it is actually 127, but partly. But class A is from 1 to 126. 127 was reserved for loopback localhost. Okay. And they now say that any IP address that starts from 1 to 126 is class A. For instance, if I have 1.50.100.250, this IP address is class A. If it is 10.10.200.251, it is still class A because the first octet, or even if you have 120.1.100.125, it is still class A. Why? Is because the first octet is of that range. That's the first octet range. Any IP address that starts from any of this range is referred to as class A IP address. And the default subnet masks of all class A's are this 255.0.0.0. It means that the first octet is used to identify the network. This is what you use to identify the network. So if I have this an IP address and have this an IP address, have this an IP address, the default subnet mask is this. Then it means that their network address is when their host IDs are all 0. You can see here that the host ID are all 0. So when they are all zeros, it is network address. Like for instance, this particular one, if I want to get the network address, it is 1.0.0.0. I only take out the network address. The 255 is saying that it's only recognizing the first octet. So when the first octet is recognized and the rest are 0, that address is a network address. So this particular one, the network address is 10.0.0.0. That's the network address. This particular one is 120.0.0.0. Why? Is because the host ID, this subnet mask, as it is, subnet mask identifies the network. So look at the way it identifies it. So when it identifies that the first octet is the network number. So when you have only the network number and the host IDs are all zeros, that network is a that address is a network address. Then coming to class B. Oh, coming to class B. Class B is any IP address that starts from this range. That means 129.1.2.3 is class B, or 130, or say 190.200.1.3 is class B. Now, and class B, they say that all class Bs, this is their subnet mask, default subnet mask, meaning that the first 2 octets belongs to the network. The first 2 octets belongs to the network. So meaning that in that case, it means that the network address of these people, of this IP address, is 129.1.0.0. That is the network address. That means your host IDs are all 0. So when your host IDs are all 0, it is a network address. Like this is 190.200.0.0. So this is a network address. Why? Because my host ID, they are all 0. My host ID, they are all 0. We don't use network address, of course, you know that. The same thing with these people. When their host IDs are all 0, it is referred to as network address. Then for class C is any IP address that starts from 192. Anyone that starts from 192 dot anything. As far as you start from 192, you can see 192.168.1.2, for instance. And the subnet mask is 255.255.255.0, meaning that from here to here, the first 3 octets are for the network. So the network address of this particular IP address is 192.168.1.0. That means the host ID is 0. Then this is a network address. This one is a network address. And what I'm showing is very important, because you don't mistaken that you don't assign network address to a host or a network device. If you mistakenly assign it, that device will not participate in the network. So it's very important you grab this, knowing what is IP address and what is network address. Because with the knowledge of this, that is what we need in subnetting. If you don't understand this, you may not understand subnetting when I start talking about subnetting, as in IP subnetting. Except you have any questions. If you don't have any question, I will screenshot. I have like less than 2 minutes. Okay. Now, from this 1.50.0.0 is actually an IP address, because this is class A, and the host IDs, they are not completely 0. There is something inside the host ID. You know that the host ID are the last 3 octets. So I have 50 inside of it. They are not completely 0. So this is an IP address. 120.2.0.0 is an IP address, because I have something inside the host ID. But this particular one is not an IP address, in as much as this one ended with 2 zeros and this one ended with 2 zeros. This one is a network address, while this one is an IP address, because of difference in their classes. This is class A. and it's supposed to be, this is supposed to be entirely the host ID, and they're not completely 0. This is class B. This is the host ID. So when they are completely 0, it is a network address. Look at this particular one now. This is a network address. Whereas 192 190.200, for instance, .1.0 is not